A particularly bizarre title, thank you for coming. Hopefully it explains itself, at least after the talk, if not before. Everybody has a who am I slide, or who is my company, mostly to sell something, or themselves, or whatever. As you can see, I'm X everything. Fortunately, however, I'm not yet an X-human being. Testing out the audience to see who laughs at the jokes. Okay, so I thought we'd have a prologue before the introduction, which is what prologues are for. As I understand it, because I don't actually do things with containers and stuff like that, that's all sort of fairly grandiose, people are not liking the JVM in containers. I have no idea why. Probably because the JVM startup time is huge, particularly when it's a restart, when it should just go, boom, straight in. Does that match with people's perceptions, experiences? Nobody's going that way. Those people who are expressing opinion are going that way. So I'm going to say, yeah, this is true, because I've seen 3 people nod. So that's called NemCon in the voting business. I also hear rumours that people are choosing Go as a programming language to replace the JVM in these containers. Does that also match with people's experience? No, 1 or 2 people saying no, quite a few people saying yes. Therefore, if anybody's been watching British television recently, you call division. Yes, order. But nobody's heckling yet, so can't do that one. Okay, so let's have an introduction, and I'm probably going to sit down. Many reasons for this, not least of which is fiddling with the kit. But also, I won't be able to stand up for 47 minutes. I'm going to let people read that. Okay, so if anybody's going to argue about this sentence, it's going to be that word. What does better mean? Is there a total order on programmer capability? Clearly not. Is there a partial order on programmer capability? Yes, there is, very much so. Partial order. And the sum of the factors in here, let's be positive for a moment and look at the positive. Better programmers produce code faster. Better programmers care about actually testing their code as opposed to throwing it over a wall and expecting someone else to deal with it. Top flight programmers still care about code size, both source and compiled. Now, I know we're not living in the 1970s where people are working with 4K of memory if you're lucky. People think 4 gig of memory is not a lot. But nonetheless, think of sending people to the moon on 4-bit computers with almost no memory. They did a lot of computation on there, and what do we do with our 4 gig? Look at pictures of cats. Top quality programmers also care about coverage, but of course those two more or less go together in some sense. And interestingly, the top level programmers really are heavily focused on the problem itself. They don't get sidetracked. And although they don't really care about YAGNI and other acronyms from the past, If you don't know what it means, go look it up and pretend you never didn't know what it meant. Focusing on the problem means providing a solution to the problem that the customer wants, whoever the customer is, but also what they need. Want and need are often very, very different things. And so top quality programmers will work on need just as much as they work on want. Better negative, speed. What do I mean there? Well, when you're caring about these things, sometimes you produce code slower than somebody who says, testing? Oh, that's for wimps. And other such awful comments. So top quality programmers can produce code slower, but they produce better code. Now, this is not the entirety of the dimensions. These are just some that have been actually measured by real people doing real experiments with real scientific method. They're probably not called computer scientists because there is no science in computer science. They're almost all psychologists looking at psychology of programming. So, the tools of one's trade are programming languages. We'll ignore things like version control and mercurial and breezy, and I suppose we better mention Git as well. Yes, those are needed. Fine, all the CI stuff needed. We're focusing here just on the programming language. And I bet most of you are Java programmers. Show of hands? Yeah, that's pretty very much. Anybody doing Kotlin? A few. Is that as well as Java or instead of? Ah, division. Yeah, it's interesting actually that Java and Kotlin can coexist in one application. That's quite nice, we like that. No talk I do can ever go by without mentioning Groovy. If you don't know why, I would suggest you go and have a look at the history of all my talks. Some people at the back actually doing Groovy, by the sound of it. Yeah, a few. Is that just because of Gradle, or doing Groovy for real? Spock. Ah, I love Spock. I also hate it. That will be a common theme. I'm sure people have heard of, if not used, Clojure. It's sort of Lisp, but not quite Lisp. We'll come to that shortly. Scala always deserves mention in this sort of a talk. That we'll understand that shortly. And JRuby always deserves a mention because of the person who develops it, who actually puts a lot of feedback into JVM development. So even if you don't use JRuby yourself, you're using some of the consequences of JRuby existing. On the other side, does anybody use C? Well, I hope not. At least not unless you realise why you have to use C. There are some situations. I've given up on C++. I do quite a lot of Python. I do quite a lot of Rust and D. Are these languages people are using or not? One or two people sort of trying not to be seen, but saying yes, they are using Rust, D and Go. Okay, so that's set the scene of the languages that we're interested in because they are the ones most people know most about. Split them into two, because you always have A and B. So imperative and declarative. And anyone who was around in the late 70s, late 80s, which is probably very, very few of you out there, but definitely me, remembers the object-oriented functional programming warfare that happened. If you weren't a functional person, you were an object-oriented person. There were no options. It really was an A-B world. But as you can see, there are other things. Procedural, as in C. Procedural language, definitely. Java is object-based. Anybody who says Java is object-oriented is wrong. And we can fight about that afterwards. Not physically, just verbally. And declarative functional logic. Yeah, I think most people were comfortable with that categorization of things. And I just want to delve a little bit into that with particular languages. But we do need to set the scene of UK child teaching. I don't know if there are any other countries following this, but kids in the age of sort of 5 through to 8 or 9 learn Scratch programming and become very good at it. If you've ever seen Scratch, it's a visual programming language, block language, and you put together lots of blocks and then they've let loops and variables and all that sort of stuff. And you make games. And kids get very, very good at it. Some kids look at it and say, bleh, but that's fine. They're not going to become professional programmers. And that is fine. So Scratch, very much a visual language, block-based language, and does a great job. And then sort of 10-ish through the rest of their primary and secondary school life, they'll be associated with Python programming. And so Python is the language that in the UK you will have to cope with in the people coming up for jobs, because they will undoubtedly know more Python than anyone in your company. Because remember, they're kids. They're learning machines. That is their job in life, is to learn stuff. Lots of sixth forms, however, are introducing a bit of Java. And one school I came across actually using Kotlin instead, because it's easier to transfer people from Python to the JVM using Kotlin. But that's just one instance, so no statistics on that. Universities, however, are very prone to teach languages like Prolog, Lisp, Haskell, or Clean. So Haskell and Clean, pure functional programming languages. Haskell is the de facto standard pure functional programming language. Prolog is the de facto standard logic programming language. There are others. And Lisp is the one true programming language. You know this because it's homoiconic. Again, if you don't know the meaning of the word, go and look it up and pretend you always knew. There are, of course, millions of other programming languages. I've invented 2 that nobody has ever heard of, which is fine. You'll notice that Fortran became Fortran. You will also notice that COBOL is still one of the most important programming languages in the world. If you didn't know that, then you haven't got a chance of earning real money. Remember that the COBOL programmers are probably the highest paid programmers in the world. And Erlang always has to be mentioned because it's just cool. As does Chapel. Does anybody do numeric programming of any sort? No, this is not the audience for that usually. But if you've got quants, and if you're a financial organisation, if you've got quants, and they think C++ is a good language, tell them Chapel's much better. And if they want to do their computations in fractions of a second rather than hours, run them in Chapel on a very big supercomputer. However, that's a sort of footnote, or, yeah. Actually, let me leave that one. We'll come back to the virtual machine native code warfare later. So we're not going to forget it, but I don't want to deal with it now. So that's the intro. What I've hoped to do is give people a feeling for what are the measures of programming languages? Where do these languages sit? And what we need is an example to just have a look at a few of these programming languages. And the problem is that you need to get the code in one page. Actually, where we are, you need to get the code in half a page because the folk at the back can't see the bottom of the screen. So we actually need to have nice, simple programs. Now, the problem with using simple programs to highlight code features is that people think, well, that's a silly program. Why does that? You have to have a bit of a suspension of disbelief. So you need to accept that the example is silly. And let's just run with it to allow ourselves to have a look at the features of the language. I'll come back and do something a little bit more realistic on a second round tour of things. But for the moment, we need to show some code. And I have to show that I actually do use editors other than Emacs, which is the one true editor. There is no other, which is why I use the Emacs bindings in IntelliJ IDEA. I also, of course, need to put on glasses because otherwise I can't see a thing. So let's have a look at Fibonacci in... you can't do that in Vim. Okay, could I get an opinion from people at the back? Is that actually visible? Or does it need to get a bit bigger? Sorry? Bigger. Let's move these guys over here. Move these guys over here. Get a bit more width. And make it a bit bigger. Still, it would be useful if I pressed Control rather than Alt. Is that doing good for people? Right, I'm going to try and make sure that the code of interest is in the top. If I slip and start doing things at the bottom, do shout out. Anyway, as you can see, it's Java and it's Fibonacci. And as we know, Fibonacci, Fn equals Fn minus 1 plus Fn minus 2. So very, very simple. And big integer is the only way of expressing bigger factorials and Fibonacci series. If you try and do it with ints or longs, you ain't going to get very far. And just as a sort of trying to justify this, in a lot of bioinformatics, Fibonacci and indeed factorial are interesting numbers. So this isn't entirely joke calculating these things. Okay, so here's the standard iterative way of doing it. So I'm using the overloading, right? So that's a feature of programming language. Is it a good thing? Is it a bad thing? I'm going to leave it as an unanswered question for the moment. It will return. But there we are using overloading so that we can have a long parameter version and a big integer parameter version. And the long parameter version just calls into the big integer valued. This seems fairly okay thing to do. Saves rewriting code, replicating code, which is more or less the same. Or is it? I mean, one of the things we could ask is, are these loops? If you're really performance intensive, are those loops acceptable? Would it be better to implement this with a long separately? Again, question I don't have an answer to because I haven't done the benchmark. But it is an interesting question. But I think most people could accept this is the sort of standard way of doing Fibonacci iteratively. You just loop up till you get to the right value of n, and you're basically doing f of n equals f of n minus 1 plus f of n minus 2. But you have to have two initial points. F of 0 equals 0, f of 1 equals 1. They're the two start points. What other ways have we got of computing this? Whoops, why? Ah, yes, of course. Well, we could do naive recursive. This is beginning to look hideous, but it's Java. Oh, that joke's not gone down too well. Java and ints and floats and stuff, you know, you've got operators like, whoops, plus and minus and other really useful operators for creating expressions. Not with big integer. You do n subtract 1, add, and you get this horrible stuff. Well, I'm sure you believe me, it's horrible. Doesn't look nice either. And then we could go down. Oh, so apologies. Why is it called naive? Because it's the first thing people write down usually. Because they think, oh, f of n equals f of n minus 1 plus f of n minus 2. Let's just implement that and use... Yeah, no, don't go there. Wrong way of thinking about algorithm as opposed to recurrence relation. So that f of n equals f of n minus 1 plus f of n minus 2 is a recurrence relation that defines the sequence of numbers. It's not the rule for computing it. And that is a crucial distinction. The performance of naive recursive is atrocious. You can think of it, it's not actually this, but you can think of it as sort of order n factorial. Now, most people like things if they're order n log n, or if you're really lucky, order n. If you're really, really lucky, order log n. And in a lovely place, order 1. This implementation of Fibonacci is truly wonderful if you like waiting for your hot computer to spin the fan off to infinity and beyond. So what's the normal way of dealing with that is memoization, and we can do memoization. What are we doing here? Showing the use of data structures, static initialization. We can do all that sort of wonderful stuff, and then you can, yeah, it's still not great, that expression, but at least the performance is getting back to something useful. Right, those are the ones I wanted to show in terms of the implementation. What about, well, let's do some Spock. Somebody mentioned Spock, so we've got to do some Spock. So here we're doing some tests on things, and we put in a few numbers, those ones we expect to work. And we've got a number of different algorithms. And so you didn't used to be able to do this sort of thing in Java, but you can now. So pointers to method objects. And here's the definition of an expected value where so on and so forth. Lots of fun stuff you still can't do in Java. Which is good stuff for Groovy. But I'm sort of not going to worry too much about this, except say, we're not even going to bother testing that one. You know, you like your test to finish in a few seconds. It ain't going to happen. A naive recursive of 10,000 is probably, even on a fast machine, going to take a few weeks. So we're not going there. And we just got a few tests that we're going to run around here. For those people who like Kotlin, we're now going to have a Kotlin appreciation moment. Come on, go down. Oh, press the right button, Winder, you silly boy. Okay, so here we are. Don't you just love being able to say 2.bigint Okay, you have to have a little bit of extra code to do that, but it is lovely stuff. And there's iterative for big integer. Oh, look at that. I can say one number plus another. You cannot believe how good this is. Java says you are not allowed to overload your operators. Java definition sucks. Okay, naive recursive looks horrible even in Kotlin because it is horrible. We can do tail recursive. If I've been trying to teach you stuff about tail recursion, that would have been useful if you're working in Haskell or Lisp or any language other than Java and Kotlin, but you can now do it in Kotlin. You can get sensible performance out of tail recursion. And that's what the tail rec is there for, because it tells the compiler to do the good stuff that Java cannot do, because it can't do tail recursion. So that's Java dead. No operators, no tail recursion. And then we get to some really fun stuff. So the foldiv one, we're going to use fold as an operator. So it's a higher order function, and it takes a value. So here's a value. It takes a closure, or whatever we want to call it in Java speak, and you take an input sequence and you fold the input sequence. So higher order functions, very much the functional programming viewpoint. Scala broke the mold on the JVM that said, yes, you can do object-oriented and functional. Kotlin has carried that on. Java is slowly picking up on this. You can't quite do fold on big integer yet, because in Java land, big integer is not a proper integral type. At least they're not throwing tomatoes at me. That's good. This is actually an important point. Higher order functions that work with all the types and work the same way with all the integral types, work the same way with all the float types. They don't separate some integral types as Java does. So nailing coffin for Java. Unless someone rewrites big integer and big float, big decimal. That would be cool if that happened. Maybe in Java 37. Another thing that Kotlin has brought is the Kotlin coroutines stuff, which is a lightweight fibers rather than threads. So threads nowadays mean operating system threads. So let's call them fibers, lightweight threads. So the coroutines solution is built on lightweight threads operating on a thread pool using Kotlin, and it's all managed for you. And what I've done here is to use the imperative implementation, but now treating it as an asynchronous program, so that you just take the next value each time you want it. Is that making sense to people? Yeah, I should go faster, shouldn't I? People are getting bored. No? Okay. Well, anyway, we've had enough of the JVM. What we should do is think about proper languages. And, okay, so you can see that I've done this for quite a few. I've done this for quite a few languages. This is me just comparing and contrasting testing frameworks. It wasn't me comparing and contrasting implementations of Fibonacci. That's just small and silly. This is me comparing and contrasting testing frameworks for each of the languages. So I guess, sorry? Ah, thank you. This is just me bragging about stuff, so it's not really that interesting. It was just giving people an opportunity. So I'm going to choose Haskell. No, I'm not. I'm going to choose Lisp. No, I'm not. I'm going to choose Prolog. Let's do some Prolog. So if we have a look at Prolog. Now, why am I looking at Prolog at all? It's because there is no concept of iteration or iterative or even imperative in Prolog. You have to change the way you think about your programming when you're working in Prolog, because a Prolog program is just a set of statements that are true. That's all it is. So Fibonacci 00 is true and is the end of the search. So the cut operator, exclamation mark, says, we found the answer. Stop looking for more answers. Because Prolog will always carry on looking for more and more answers that meet the criteria. So the cut operator there is to stop a search and say, we found the answer. Stop. And so Fibonacci of a number and a result is defined as being this thing which, Prolog is not an imperative language. Doing assignment is an imperative thing, so Prolog makes it hard, which is fair dues. And you're going to say, well, does it work? Well, let's find out. So if I start up the SWI Prolog system and read the Fibonacci as the initial file, I can ask questions like Fibonacci 3, what's the third? Probably 8. And dot says I finished my query. Oh. So the way of working in Prolog is not, can you write me out the answer? You can do that in Prolog. It just violates the whole way of working in Prolog. Prolog, you ask a question and it tells you whether that's true or false. It must be 5 then. No. Whoops. 3. Yay. So the third item in the Fibonacci sequence is 3. 0, 1, 1, 2, 3. Yeah. Okay. Why have we looked at a Prolog? It's really to highly emphasize this nature of your code is declarative statements. The computation happens when you ask a question. And the computation in this case is a system called unification, which takes the rules in, takes your question, and tries to find, in this case, an N and an R for which the statement is true. That's what you want to do. So very different from Java thinking. Prolog is perhaps the most declarative of programming languages, which is a good place to have a look if you really want to challenge your idea of algorithm. And that's really where Prolog... also, of course, the first version of Erlang was written in Prolog, which is why Erlang syntax looks suspiciously like Prolog. Okay, that's enough on that. Oh, too much waffle, not enough action. So let's have a look at D. So we can actually run and make sure that all the tests pass. Okay, so let's have a look at the, what was it called? Implementations. No, Fibonacci. Whoops. Okay, so here's a programming language D. looks a little bit like C++, only a lot better. The original intention of D was to be C++, only better. And it's been around a while, but it always stays better than C++. No matter how good C++ gets in C++ 14, C++ 17, C++ 20, D is always one step ahead. I can back that claim up, just not in the next 14 minutes. So we can have a look at, I could have a look at iterative. Everyone looks the same because the iterative algorithm in any language that has any form of imperative nature, it will look the same, more or less. But the declarative version, the font's a bit too big, really, for the way I've done it. But what you can see here is that there's a function, higher order function, that executes this, I say Clojure, on these initial values. So here are the initial values. It executes this function over those initial values, but it's lazy. Aha, lazy evaluation. Similar to streams in Java and what you can do in Kotlin. And here we have it in native codes. C++ can't really do this yet. It will be able to fairly soon. So recurrence sets up a lazy list. We then say, well, we actually want to drop the first n. Again, still fairly lazy. And then we want to take the first one on the list that's left. And remember, we've now got pairs because it's a pair, big int 0, big int 1 with a start point. And at each stage, we calculate the Fibonacci number, the current one and the previous one. And so we want to take the front item, and that then causes the evaluation. So it's a pull mechanism. Streams are doing that now as well. So Java has that concept. We also got recursive. And, oh, the tests are in the file. Not separately. Your unit tests are in the same file. Now, do you consider that a good thing or a bad thing? Those who want to say good. Those who want to say bad. One or two. It is actually a personal opinion. There is no absolute answer to that. But what there is if it's the right thing to do in the language, then you do it. So with Java, it's generally the right thing to do to have the tests separately from your main code. In D, you put the unit tests in the module, the same file, and the functional tests separately. So each programming language will come with its own model of what to do. And so this is just doing tests. And, here's property-based testing versus example-based testing. With the Java language, I showed a set of examples. Here, what you do is you say, for some type ubyte, choose 100 instances and run the test and see if any of them fail. And that's really what property-based testing is about. You provide a property, a Boolean expression, and here, the fact that it's f of a plus 2 equals f of a plus 1 plus f of a recurrence relation. The relation maps very nicely to a Boolean property. Now that is a good mapping, because that's nothing to do with algorithm. It's to do with the relationships between values. And so property-based testing is a really cool thing. In my example here, done fairly simply. But go away and look it all up. If you're not doing property-based testing, you should be. Okay, so let me just go back up here. because I wanted to show a little bit more complex stuff. And because you wanted it to be real code, I thought I'll do real code. You probably don't watch digital video broadcasting because the entire universe now works on streaming over the internet. But I've got a metered internet. So during the day, if I want to watch telly, I have to do DVB, Freeview. So I have an interest in doing Freeview. And so what we've got down here is a Rust version of it. And we actually need a file to look at. Let's have a look at this one. Okay, I suppose I should have shown it in action, shouldn't I? First, before. So the only channel I was able to get last night in here was BBC News. There you go. And you can have it twice if you really want. As I say, none of the other channels will work because this is my aerial and we're inside. And yeah, this is a very, very poor computer for doing this. But really this is what I wanted to do. I wanted to have the two games going on from the Indian Premier League. No, you don't care. I care a lot. Okay, so that's really what it was about. It's about getting television on there. And, it's also about... I've got time. It's also about doing this. Oh, come on. Yes. You'll notice that my television has 2 tuners in it. Yes. You should see me when I'm testing. I've got like 5 of these things going. It's quite fun. Anyway, that's enough of the actual application itself. What about some Rust? Well, you use things, you pull in modules, all languages are the same these days, except C++, which doesn't have modules yet. And this is a GTK and GStreamer application. This is the GTK doing the windows on the screen, and this is actually the control window that we're having a look at. And you can see it does things with structs, whereas in D you would do things with inheritance because it's object-oriented, whereas Rust is very much object-based. So you have struct definitions, and then you can have functions associated with the struct. So in Kotlin you'd probably call, thingy functions? Curses, I can't remember, spontaneously failing to remember the term that the Kotlin folk use for this. But you're basically attaching functions to the use of the instances of the type of struct. So no inheritance. People coming from Java will say, what? Go use D, because D's got inheritance. Rust does not. Why am I using Rust for this? I was using D, but then the GStreamer community decided Rust was the language of the future. So everything in GStreamer is going to be Rust-oriented. So I thought, I'm going to rewrite it in Rust. But then I discovered this bit. Effectively going to leave this bit as the really cool bit of code. You probably saw it whistling past, but there was an enum definition. And enums are weird in Rust because you can have state associated with each of your enum type. So here I've got enum types, front end appeared, front end disappeared, target keystroke received. Well, the front end appeared, front end disappeared, I showed when I unplugged the USB. And what did we do? Well, we executed add front end and remove front end. Why is this interesting? The listener for the USB is separate from the GTK event loop. And so what this is doing is attaching to the event loop a Clojure which receives messages on a channel, and then in the GTK event loop calls the relevant. So you're connecting an actor out there to the GTK event loop. Now, event loops tend to be really important in computing these days. Being able to do it so simply as this is wonderful. Now, Kotlin has nearly got there, but not for GTK. Java is maybe catching up soon, particularly if some of the JSRs get taken on board. Okay, so that's been a much swifter look round some languages to give you basically a feel for the syntax, and I've highlighted one or two really interesting things of the semantics of them. So what I would like to do, did I show the code? Yeah, mostly. Is say reactive and asynchronous is probably a programming paradigm that was missing from that original list, because the way you have to think when you're doing asynchronous programming is very, very different. But being able to use classic control flow mechanisms to construct asynchronous code strikes me as being a good thing. Better than being functional or object-oriented or anything like that. It just helps stuff brilliantly. So a few conclusions. I've got 2 minutes left, I think. Yep. The VM versus native. Well, how big is the Java virtual machine? Would it fit in 4K? No way. Yeah, I mean, you're lucky if you start at sort of 200 meg. And that's if you're really lucky. Native code, 200 meg, you've got the whole thing in 10 times. And that's almost certainly part of the original problem from the Prolog startup time, is just the size. Virtual machine-based code is platform agnostic. That was the whole point of Java in the first place, was to be the operating system for your washing machine. It had nothing to do with the web. It was all about white goods and brown goods, which is still programmed in C, because Java failed. Remember that Java, Oak, failed. It was just too soon, because they had iPads and things in 1981. Love the history. Most people suggest, though, that garbage collection is a good thing. Yeah, I agree. And VM systems invariably have garbage collection. And out there in the C++ world, if you mention the word garbage collection, you will be hung, drawn and quartered. Almost certainly. If you mention garbage collection in the Rust community, they'll say, what's that? In the D community, it's there. You've got garbage collection. So it depends on the language. But there is the point of you have to recompile everything. That is still true. For a new architecture, you've got to recompile. But is Java that protected against being platform agnostic? Can you run your Java 1.4 code on your Java 12 instance that you're running in production? Probably not. Imperative versus declarative. Basically, we're seeing a joining of the ideas of one into the other. Fold in D and other languages. Reduce, map, filter. All these higher order functions are proof of the integration of the ideas of object-oriented and functional. And so we really do have to remember that Scala broke the mold for the JVM in bringing that about. Would I use Java or Kotlin for MeTV? No way. Why JVM? Absolutely no point. Would I use Go for me TV? We didn't actually look at any Go, but you generally find for a given problem, your Go code is that big and your D or Rust code is that big because of the higher order functions. You don't get those in Go. Go is a very low level language. D or Rust? Yes, obviously. Epilogue? Just going to let people read them. Yep. Do not stop learning new languages. That's the moral of this, more than anything else. I've got a red, it says time's up. It's been showing for about 15 seconds, so I'm well over time. I do apologise for that. Thank you for coming. If you want to hassle me, you're most welcome. Thank you very much.